an article that just published on BBC about how to stop AI agents going rogue. And it's actually not a bad article describing what an agent is. So a lot of people are using the term agent indiscriminately. Agent has become the new marketing term. It's just something you add on. Last year, you just added the word AI. Now you add the word agent or agentic, basically. But a lot of what people shill as agents are not agents. They're just AI automations, and they don't actually have any agentic behavior. So I thought there was a decent definition of what an agent is here. Remember that we have lots of definitions. We have too many definitions of this, but we don't have an agreed upon definition. So this is, I'm not even going to try to pronounce that name because I'm going to get it wrong and I'm going to get in trouble. It looks like a Gaelic or a Celtic name. I'm going to say Donna Casey, CEO of Calypso AI, a US-based security company. He says, an AI agent consists of a few things, and I'm sorry for definitely getting your name wrong. Firstly, the agent has an intent or purpose. Why am I here? What is my job? The second thing, it's got a brain. That's the AI model. The third thing is tools, which could be other systems or databases and a way of communicating with them. I think that is a solid definition. So 3 things again, an intent or purpose. So whenever we create an agent, we give it a goal. This is what you're created for. This is what you're going to do. Why am I here? What's my job? I don't think that's useful language, because that reminds me of that Rick and Morty, the little robot that moves the salt shaker about. And when it realizes that's its life's purpose, it gets depressed. But yes, we need to give an agent a goal. This is what you're working towards. And if you get the goal done, great, kudos, points. If you don't get it done, negative, and then we use it to reinforce it. The second thing, it's got a brain. That's the AI model. So in most cases, it's going to be generative AI. It's going to be a large language model. And then the third thing is tools, which could be other systems or databases or a way of communicating with them. So a limitation of a lot of our AIs is that they don't have access to the rest of the world. So it relies on us as human beings to feed in the information. So as soon as we give an AI access to our computer or our development interface, for example, or development server, or to all of the documentation inside our organization, when we give all of this to an artificial intelligence, it's much better able to get done what it needs to get done, to move towards that goal, because it doesn't have that limitation of requiring the human operator to come in and tell it what to do, what tools to use it with, etc. However, and he goes on to say this, if not given the right guidance, agentic AI will achieve a goal in whatever way it can, and that creates a lot of risk. So the famous example here is the paperclip example, which I think it's from Nick Bostrom's Superintelligence book, but there's also a really good video game called Universal Paperclips, which is this idea of an AI where if you give it the goal, if you give it the purpose of create paperclips, or specifically create as many paperclips as you can, and that's its only goal, the logical thing to do, eventually, this AI will follow that instruction to what we would consider an insane or an obscene limit. It will basically strip mine all the resources from Earth. It will realize that humans are getting in the way of it trying to make paperclips, so it will probably get rid of us, and it will turn us to mush and turn us into paperclips. It will build a Dyson sphere around the sun in order to power its paperclip factories, etc., because it's all aiming at one goal, and it won't let anything, including humans, get in the way of that. So this is one of the ideas of a rogue AI, is that it won't destroy us and kill off humanity because it's malicious. It would do so because it's trying to reach a larger goal that we, the humans, have given it, and it's trying to do that at all costs. So we'd have to specifically put in things like, hey, don't drain the oceans to cool your paperclip factory, or please don't withdraw all our energy off the power, leaving us in the dark in order to power your factories. We'd have to give it all of these strictures and rules as well. And it's really hard to come up with all of them beforehand, to give all of the rules. So we had a form of AI, and it was rules-based, basically. And this was one of the earlier forms of AI. And somebody, I forgot the name of the system, but somebody tried to basically write all of the rules of human knowledge into this system. I'll have to look it up because it's a fascinating piece of history. They're like, if we give it all of the rules of how things work, then we'll be able to create intelligence. So all we need to do is explicitly write all these things down. So there are things like, you've got a mug. If you have a coffee mug, you need to put it on a mat on the table. Cool. But then they had to write explicit rules for absolutely everything. Oh, don't leave your coffee mug on the carpet. Okay, cool, we'll write that in. And as you can imagine, this just expanded and it was just impossible. These were humans typing in these rules. And they were trying to capture all of the implicit knowledge that we have in our head into explicit rules for a computer. And very quickly they realized that, no, we can't do this. There are so many things that we as humans implicitly know and we don't think about as like rules. They're just things that we do. And trying to capture that is almost impossible. This is one of the issues with agentic or agents, is that they will act in a way that we can't necessarily predict because they're trying to reach a goal. And unless we write down all the guardrails and all of the strictures, they might find a weird way to reach that goal, which we as humans will look at in horror and be like, no, that's entirely wrong. But there's no way for the AI to know that because all it's doing is focusing on its goal. So this is a whole article on the BBC, well worth having a look at. But the reason I wanted to mention it is I saw this useful post over on Reddit. And often there's a lot of noise over on Reddit, especially after the GPT-5 release. It was chaos. But there's a guy here basically put together a step-by-step roadmap for if you want to build agents. And he says, everyone keeps asking for a step-by-step roadmap. They want a list of frameworks and courses. That's a trap. I've been building these systems for years, and the only path that works is learning the concepts in the right order. This isn't about specific tools, it's about the mental models. And then he goes ahead and he lays out 4 or 5 different phases. So I'm just going to go through them because I thought this was really useful. So the first one, phase 0, is the toy. Stop reading tutorials. Seriously, pick one PDF, your resume, a Wikipedia article, anything, and build a chatbot that can answer questions about it. Use LangChain or Llama Index. Don't worry about the UI. Don't worry if it's slow. The only goal is to understand how a prompt, a context window, and an LLM actually fit together. You need to feel the limitations of basic RAG, retrieval augmented generation, before you can appreciate anything else. So he says, stop reading, stop studying, just go and build a little fun toy project. It's not going to be useful, probably won't work, but that allows you to get to grips with how these things fit together. I think this is really useful for anything that you're learning. You need to do something. So I help teach people about entrepreneurship. And one of the things I tell them is just stop reading, stop studying, just go and start something. And it's going to be rubbish and it's not going to work and you're not going to make any money. And that's fine because you're going to start learning from that process. Phase 1. So phase 0 is the toy. Phase 1 is the tool user. Now, give your bot a single tool, one tool, a calculator, a weather API, anything. This is where you move from a search bot to an actual agent. The real challenge isn't calling the API, it's fighting with prompt engineering to make the agent reliably understand when to use the tool versus just making up an answer. So you've built a very basic chatbot here, and now you're connecting it to some kind of external tool. So just one tool, and you're making sure that it knows how to use that tool and it doesn't get it wrong, which it will most of the time. Phase 2, the orchestrator. One agent can't do anything very well. Sorry, one agent can't do everything. Now build a system of specialized agents. So you're going to have multiple agents connected to this large language model in the middle. An orchestrator agent, its only job is to receive a request and route it to the correct specialist, like a billing agent, a support agent, etc. This is where your simple script becomes a real system and you're forced to think about state management and how agents communicate. So this is building an ecosystem of different agents that are all communicating, and the task is being sent to the right one, and then probably information from one being sent to others, and you have an orchestrator in the middle which is making sure it's going in the right direction. So it starts to look like building a business at this point, or building a team of people, and you need to be thinking in that kind of systems logic in order to get it working. Phase 3, the memory. An agent without memory is just a function call. It can't have a real conversation. Now, give your agents memory. Start with simple conversation history, then move to a vector database for long-term recall. So it's going to remember everything that you've done with it before. The hard part isn't storing the memory, it's retrieving only the relevant parts without cluttering the context window. So context window, we've talked about this before, is basically the memory of a large language model. It is all of the input and output information fall within this context window. And if you run out of context window, then the AI is going to start making things up. It will start to hallucinate, to fill in the gaps. It's very easy to store everything. Let's say we're using our AI agent and we're storing absolutely everything into a vector database. Cool, that's great, but that's not very useful. We just have a big splurge, a data dump of information. We need to be able to provide the correct context to the agent at the right time. That's the difficult part. And then phase 4, the guardrails. This is where most projects fail in the real world. An agent can do anything. Oh, an agent that can do anything is an agent that can do anything wrong. Now you need to learn how to say no. Build hard rules, output validation, and content filters. This is where you learn about red teaming, evaluation frameworks, and the art of making an agent say, I don't know, instead of lying, which is a hard job in artificial intelligence. So this is when you are preparing your agent to go to build it into a piece of software, for example, because if it's internal for you and it's making mistakes, it's not the end of the world. You can probably fix them manually, but the whole point of an agent, it is autonomous. You should be able to step back, but you can still fix things if it's just private. If you are releasing it as a piece of software or you're building it for a client, you can't have it going wrong, because again, an agentic system, when left to its own devices, can wreak absolute havoc, because we're connecting it into parts of our business or parts of our organization that, if it changes, if it messes around with them, could be devastating. And then phase X, the final phase, the real world. Everything above is a sandbox. The real world work starts now. You deploy, you learn about latency, monitoring, and observability. You build feedback loops so that agent learns from its mistakes. You deal with data privacy, compliance, and user trust. This phase never ends. You just get better at this loop. That's it. That's the path. Stop chasing the perfect stack and start solving these problems in order. The real skill is in the transition between these phases. So again, very briefly, phase 0 is the toy. Just mess around with building a basic system. You just need to get started, get your hands dirty. Don't keep reading about these things, but start to build. Use LangChain, it's fine. Phase 1, the tool user. So you're going to connect your chatbot to one tool, make sure that it works. Phase 2, you're going to add different tools and an orchestrator, part of the AI that's going to orchestrate the correct tools. Phase 3 is adding a memory, not just a large vector database where you dump all the conversations, but an ability to recall the correct things at the right time. That's the hard part. Phase 4 is the guardrails, starting to prepare it for the limelight, for public release, for your client or your customer, and red teaming it, basically trying to break it in order to find how it's going to go wrong in the real world, and then fixing those problems before they occur, and then deploying it into the real world, building feedback systems, and continuing to make it better and better. So I thought this was a really useful framework. This is not mine. This is from Reddit. He does not have enough upvotes. He really should. But this is a much better answer than how should I build, like what tool should I use? Should I use NA10? Yeah, sure. Should I use, you can use whatever tool you want. That doesn't really matter. This is what's important, is what you're going to build for, what problem are you going to solve, and then building step by step through these phases. That's more important than what tool you use, because you can use multiple tools and get this same work done.